In this lesson, we're going to talk about the chain rule, and a chain rule is a method used when differentiating composite functions. What is a composite function? A composite function is a function that has another function inside itself. A good example is what you can see here. Y is the main function, but inside the y function, there is another function 2x plus 4. To differentiate the composite functions, we use the chain rule method of differentiation, which states that change in y due to change in x is equals to change in y due to change in u. You multiply change in u due to change in x. And as you can see from this chain rule formula, we need to find change in y due to change in u and change in u due to change in x. U is the linking function that is going to help us to find the derivative of our composite function. How do we identify the u from the composite function? The function inside the main function is always our u. In this case, u is equals to 2x plus 4. And if u is equals to x plus 4, then y transforms into u raised to the power of 6. The next thing we're going to do is we find the derivative of u and the derivative of y. So we start with the derivative of u, that is change in u due to change in x. We are going to differentiate the u function. When you differentiate the u function, in this case, you get a 2. And then you find change in y due to change in u. We differentiate the y function with respect to u. You get 6u raised to the power of 5. The next thing you're going to do is we substitute the derivative of u and the derivative of y in the chain rule formula. That is, change in y due to change in x is equals to change in y due to change in u, which is this function, 6u raised to the power of 5. You multiply by change in u, change in x. Change in u, change in x is this value here, that is a 2. And from here, you just simplify. That is, change in y due to change in x is equals to 6 times 2. You get a 12, then you multiply by u raised to the power of 5. But you need to ask ourselves, what was our u? Our u was equals to 2x plus 4. And hence, our final differentiation will be change in y due to change in x is equals to 12 into bracket 2x plus 4. You close the bracket, then you raise it to the power of 5. And this is the final derivative of our composite function of y. We have another example too, and you're told find change in y due to change in x of the following function. To be able to differentiate this function, we need to make some adjustments using the laws of indices. To learn more about the laws of indices, you can follow the link above or the link on the description box. Using the fractional law of indices, y can also be written as y equals 2x plus 3. You raise it to the power of a half. The next thing you're going to do is identify the u. The u is always the function inside, and therefore u is equals to 2x plus 3, and hence y will be equal to u raise it to the power of a half. Now that we have the u and the y, we can find change in u due to change in x. We differentiate the u function, and when you differentiate the u function, you're going to get a 2. Then you're going to find change in y due to change in u. We differentiate the y function with respect to u. That is going to give us half u raised to the power of negative a half. Then you're going to write the chain rule formula. That is, change in y due to change in x is equals to change in y due to change in u. You multiply by change in u due to change in x. After that, we take these derivatives here. We substitute them to the chain rule formula to find the derivative of y. That is, change in y due to change in x is equals to, we identify change in y due to change in u. And in this case, this is our change in y, change in u. That is a half u raised to the power of negative half. We multiply by change in u due to change in x. Change in u due to change in x is a 2. So we multiply by a 2. And we can simplify our equation by 2, 1 by 2, 1 to get change in y due to change in x is equals to u raised to the power of negative half. You see the negative power law of indices. This one can also be written as change in y due to change in x is equals to 1 over the square root of u. But what was our u? Our u was 2x plus 3. And therefore, the final derivative, you're going to get change in y due to change in x is equals to 1 over the square root of 2x plus 3. Let us look at example 3. We are told, find the derivative of the following function. To differentiate this composite function, we need to use the laws of indices to make some adjustments. And using the law of indices, using the negative power law, the function y can also be written as 2 into bracket 2x squared minus 3 raised to the power of negative 4. Then you're going to identify the u. The u is the function inside. That is u is equals to 2x squared minus 3. And that is going to transform our y into the form 2u raised to the power of negative 4. Now that we have the u and the y, we need to find change in u due to change in x. We differentiate the function u with respect to x, and that is going to give us 4x. And then we find change in y due to change in u. We differentiate the y function with respect to u, and that is going to give us negative 8u raised to the power of negative 5. Then we are going to write the chain rule, that is change in y due to change in x is equals to change in y due to change in u. You multiply change in u due to change in x. After that, we need to take these derivatives of u and y. We substitute them to the chain rule to get the derivative of y. That is, change in y due to change in x is equals to, we identify change in y, change in u. Change in y, change in u is this derivative, negative 8u raised to the power of negative 5. We multiply of change in u, change in x. Derivative of change in u, change in x is 4x. So we multiply by 4x. Then we simplify our equation, that is change in y, change in x is equals to, we multiply negative 8 with 4x, and that is going to give us negative 32x u raised to the power of negative 5. Using the negative power law of indices, we can write this as change in y due to change in x is equals to negative 32x divided by u raised to the power of 5. But our u was equals to x squared minus 3. And therefore, the final derivative will be change in y due to change in x is equals to negative 32x divided by, into brackets, 2x squared minus 3 u raised to the power of 5. We have our final example, and we are told differentiate the function with respect to x. This composite function, for us to differentiate, we need to use the laws of indices to make some adjustments. And we are going to apply two laws of indices here. One is the fractional power law and the negative power law. And that is going to give us y is equals to 6 into bracket 2 minus 3x into bracket u raised to the power of negative a third. Then you're going to identify the u. The u is a function inside, hence u is equals to 2 minus 3x. Therefore, y will be equal to 6u u raised to the power of negative a third. Then you're going to find change in u due to change in x. We differentiate the u function with respect to x, and that is going to give us negative 3. Then we find change in y due to change in u. We are going to differentiate the y function with respect to u, and that is going to give us a negative 2u raised to the power of negative 4 over 3. The next thing you're going to do is we write the chain rule, that is change in y due to change in x is equals to change in y due to change in u. You multiply by change in u due to change in x. The other thing you're going to do is we take the derivative of u and the derivative of y, we substitute them in the chain rule formula to get the derivative of our function y. That is, change in y due to change in x will be equal to, we identify change in y due to change in u, which is this function, that is negative 2u raised to the power of negative 4 over 3. Then we multiply by change in u due to change in x. Change in u due to change in x is negative 3. So we multiply by a negative 3. Then we simplify our equation, that is change in y due to change in x is equals to, you multiply -2 with a -3, and that is going to give us a +6. Then u raised to the power of -4 over 3. Using the negative power law of indices and the fractional law of indices, we can rewrite our function as change in y due to change in x is equals to 6 over u, you find the cube root, then you raise it to the power of 4. But our u was equals to 2 minus 3x, and therefore the final derivative, that is change in y due to change in x, is equals to 6 divided by the third root of 2 minus 3x into bracket raised to the power of 4. And this is the final derivative of a y composite function. That brings us to the end of our discussion. Hoping the video is going to be of help to you. Thank you for watching. Hoping to see you next time.